Hi there, welcome to my channel Mando to Fundo. In this video, I am going to discuss about the solution for checking whether a string has a subsequence. Let's look at the problem description. We are given two strings s and t, and we have to return true if s is a subsequence of t. So definition of the subsequence of a string is a new string that is formed from the original string by deleting some of the characters without disturbing the relative positions of the remaining characters. So in this case ACE. So in this string the ACE are in the same order as it is in this string. But if they give AEC, but that is not, E is not coming second, so in that case it's not a subsequence. So let's look at this example ABC. So here in this string B, if we delete H, G, D, then we get ABC. So S is the subsequence of the string T. So in this case A is there, we delete H, B, G, D, and then we are seeing C instead of X, so that means we have to return false. Let's see how we can solve this problem using the two-pointer approach. So the index I points to the first character of the longer string and J points to the starting character of the smaller string, and we iterate over the bigger string, and whenever there is a match we advance the J pointer. For each iteration we check whether that character matches the character present at the index J in the small string. In that case we increment the J index. So we loop through this, either one of the strings end is reached first, then we come out and then we will check whether J is less than the length of this. If so, we return false, otherwise we return true. Let's look at the flowchart. Input for this procedure is two strings, one is smaller and larger, and we initialize the indexes SL to 0, and the return value is initialized to true. So basically this is a loop which iterate over the longer string, and we check whether pointer S is reached S end of the smaller string, or the L is reached the end of the larger string. If no, then the characters pointed by the index S in smaller string and index L in larger string are matched. If they are matching, then both the indexes are incremented and it will proceed to the next iteration. Otherwise, only the index I is incremented. So once this loop is finished, then it is checked whether the index S is reached the end of the smaller string. If so, then that means this smaller string is present in the larger string, so we return true. Otherwise, we set the return value to false, and then the false will be returned. Let's move on to coding. First I change the input string's name for readability purpose. Then initialize the pointer S to 0, and then in this for loop I'll iterate over the longer string, and also this for loop will exit when either one of the strings is fully processed, and then we check whether the character pointed by the pointer S and pointer L are equal. If so, we increment the pointer S, and then once we come out of the loop, I check whether pointer S is less than the length of smaller string. If so, there are some outstanding elements in the smaller string, so we return false. Otherwise, return true. Now I'm going to run this program, run some test cases for this program. Okay, it's accepted. Next, I'm going to submit this program. Cool, it's accepted. Next, I do code walkthrough with sample input. So the input has two strings. The smaller string is ABC and the larger string is AHBGDC. So in the first iteration, both the index L and S points to the first character, and we check whether it is matching. Yes, it is. Then we increment the this index S. So the index S pointing to the next character, and the for loop moves the index L to the next position. So we check whether these two are matching. No. And instead of in this case, we do not increment the index S, and index L will be incremented. So these two values are compared, they are matching, then index S will be incremented. So it is pointing here, and the next iteration it points to G, and they are not matching, so it remains here, and the for loop advances this index L to the next position and then to the next position. At that time, both the characters are matching, so we increment the index S plus plus. So when we come out of the loop, we check whether S is less than smaller to verify whether we process all the characters in the smaller string. So if it is less than the length of the smaller string, then that means there is some more elements, so we return false. Otherwise, we return true. Next, I'm going to do the time and space complexity analysis for this solution. So I do the time complexity for two cases. The first case, the smaller string has ABC and the larger has ABCHD. So in this case, how many times this for loop runs? So the moment we process all the elements in the smaller string, we break out of the loop. So we check here, and so in this case the for loop runs 3 times. And then for this input case, this for loop runs 6 times. So because all the matching character is at the end of the larger input string, so we have to iterate over the entire larger string, which is of length 6. So the runtime is 6. So the time complexity for this algorithm is order of n, where n is the length of larger string for the worst case. And the space complexity is order of 1 because we do not allocate any additional space with respect to the input size. So the space complexity is order of 1. Thanks for watching this video. Have a great day.